Okay, so thank you everyone for joining in this part of the session today. So today I would like to talk to you about a little bit of the .NET Spire, but actually taking advantage of this technology in order to build event-driven application and also include as part of your architecture and your development process, the CQRS process. So before moving to the .NET Aspire, we are going to cover a couple of things. Initially, we are going to speak what is CQRS. We are going to talk about something that actually plays very well with it, which is the vertical slicing. This is another good practice that is getting very popular today in order to build your code. After that, we are going to be jumping into the code. We are going to see a couple of things, how to integrate the code using CQRS and take advantage of services like Service Bus. We are going to have an integration with Cosmos DB as well. And of course, we are going to be using SignAlarm, which is an extraordinary part in order to build event-driven applications. And after that, I will be open to any questions. So let's start at the beginning. What is CQRS? So CQRS is just a shortcut for common query segregation responsibility. And this is actually let's call it an old pattern and actually already defined a way in order to build your code. So technically, this kind of architectural coding design is going to allow you or propose you to write your code as structured as possible. Why is that? Because you will be able to write any operation that is to retrieve information into the database written as queries. That means anything that you go to the database where you have to retrieve several items, a single item or something similar is going to be treated as a query. For the other hand, when you try to manipulate data, you want to store something into the database or make a partial update into the data, you are going to be using a command. And in this part, this actually becomes pretty important to mention that we have a segregation of responsibility in here. Because contrary to the usual vertical, of the onion architecture or the domain-driven architecture that we usually see throughout the application, we are not going to be seeking anymore to split the code into several layers and try to make sure one of those layers actually solve one particular piece of the code. Instead, we are going to be diving back, getting all those things together, but they are going to be treated as individual components. So instead of having a layer of services providing shared solutions throughout the application, each particular feature of the system that you are going to be building is going to be treated as an individual component and a single piece into your code. So one of the things that CQRS implementation actually fixes and also provides a great solution in conjunction with vertical slicing is that you stop sharing services throughout the application. So you no longer write a single database access layer for the whole application, or you do not create services that are shared between multiple implementations. That way, this actually removes the coupling between classes because each particular piece of the design is going to be an individual component. So you no longer, as a developer, will have to worry about changing one place of the application and maybe fear to break another place of the application, but instead everything is going to be so isolated and treated as an individual piece that you will be able to remove that part of the concern into the code. So this plays actually pretty good also with vertical slicing, which is actually a very close definition that I just gave. So instead of having like multiple projects trying to treat everything, you only will have maybe one or actually two levels of abstraction in your application. You will usually have the web or the API, and in the middle you will have a domain layer where all your code is going to be sitting. We are going to see in a moment how the vertical slicing actually is pretty helpful to split the use cases in your application and how it actually organizes these kind of things. So if you take a look into the image at the right, you will see that we have a web or a particular piece of the application that is going to consume a set of features instead of having like an application, a domain, or a database layer separated between the different parts of the system. Instead, you are going to have vertical pieces trying to solve one particular feature of the product that you are working on. So in order to understand that, of course, it's way easier if we take a look into the code. So I'm going to go into my area and I'm going to show you how this plays together. So the first thing that I would like you to take a look is into this domain layer. So as you can see, we have the usual structure that you have been seeing throughout the day. In this session, we have the app host, which is going to hold all the infrastructure and the definition and the reference between the different services that we have in our application in this case. And also we have an API, we have a web app. This is just a web application, and we have a worker service. So as you can see, we have 3 different products here installed into the solution. Each one is going to provide a different level of solution. All of them are going to be taking advantage of this domain layer that you can see in here. And one of the first thing that you will notice is that the application is going to be split into different features. For this demo today, I actually just prepared a very simple store application that is going to save some data from the product ID and price and the quantity of the orders that the user is making, something pretty simple. But as you can see, even in the most simple case scenario, we make a proper split of the cases. So here in place actually comes pretty handful. The libraries like media TR in order to implement the CQRS structure in here. So if you are already familiar with media TR and part of the CQRS, you usually provide an operation, which I mentioned. It could be a command, it could be a query. In this case, for NLX, in the example we are seeing on screen, it is a command because we are saving information in one place into the database. We have a handler which is going to interact with the media TR definition all together with the command to store information to the database. And we have a set of models and responses that we can use in order to exchange information between the consumers of this feature in particular and the implementation itself. So this is a pretty easy example. That you can see we have the media TR here in place. We are using a mediator in this case to handle the proposal of the solution that we need to have. And we have a command to treat the information. And the code is actually pretty simple. As you can see, nothing besides the particular services that I actually need from outside components are being used in here. So we have a service bus client, and we will be seeing in a moment the integration in the app bus for these resources. But besides that, as you can see, this particular class is only consuming this client and defining his unique logic. So we are not sharing services anymore in the throughout the abstraction in our products. If we take a look into, let's say, into a get buy orders in this case, we see we have a pretty similar structure, but in this case, we have something that is defined as a query. This is just a retrieve operation defining here. And in the same level of structure, we have a handler that accesses, in this case, the database. So as you can see, you have the same level of abstraction in here. We are only using those resources that are defined globally through the application, like the DB context, but instead of creating factories or centralized places to access the data, we have everything set in place in here, and this is only trying to solve one particular case of the system. So this is one of the biggest promises of CQRS, that you can split your logic into a smaller feature and solve these kind of problems. But be wary, CQRS is not meant for every system. Truly, it will depend on the use cases that you have. If you have a system that is going to be escalating pretty big, it's going to be a big API, a big web app, and is going to be sharing logic between different components at the same level, or could have a benefit from that, you will be best served with CQRS. If you are building very small services that maybe do not have a negative impact when you make changes throughout the system, you will be best served to use a more classical architecture in this case. So be wary. CQRS is an excellent resource, but it doesn't mean that you can be using it everywhere or you need to adopt it everywhere. So going back to the good definition, when you will build an application using CQRS, it is very likely that you are building an event-driven application. So that means instead of making the usual HTTP request, going to a particular API and wait for the response into the service, you are using components that work async between them, and they have a very small cohesion between them because they act on their own. This increases the data resiliency, the system scalability, and everything. And we already know the Azure provides this kind of solution with service bus queues, Cosmos database, SQL databases. We have event hubs, we have event grids, we have a bunch of systems that are going to allow us to exchange communication between components without waiting for a proper response. So the first thing we are going to be using in this demo is actually a service bus. We are going to be using it in order to build our solution in here. So when the user is going to set up a request to our system, this is going to place a message into the service bus instead just making a direct interaction with the database throughout the API. And the service bus is actually going to be consumed by another service in here. In the code example, we have a worker service that is going to be opening a connection into the service bus and is going to be consuming in here. So we have a producer system in here and another consumer that is going to be acting between the requests that the user make and through our systems. So also to expand the good example of data administration and sharing data throughout our global resources, which is actually something pretty common also in event-driven application. In this case, I choose to use Cosmos DB also to show you how easily we can implement Cosmos DB as part of our solution using Aspire.net. Just get the proper NuGet package and access the add Azure Cosmos DB and just provide a name for the resource that you would like to share throughout the application. In here, since we create the Cosmos DB service, we need to provide a database. In this case, we are going to provide the store definition inside the Azure portal for this database. One particular piece that is actually pretty important with building an event-driven application is async communication. So one service that is also going to be very proficient to notify between different components what happens in these messages exchange is using SignAlert. SignAlert is going to provide that async communication. Multiple components can connect to the SignAlert service. We can do it via the front end. We can do it via the backend. Is pretty open to connect with whatever place that you would like to have, whatever is for sending messages or actually receiving those messages and consuming those messages after they arrive. So as you can see, adding the SignAlert is actually pretty simple too. Nothing overcomplicated for it. And now that we have the resources that we are going to use, we have the service bus, Cosmos, and SignAlert, we would like to start making an integration between those components. So we will be serving a web API, which is going to be consuming the service bus, which is going to be consuming the Cosmos instance as well, and the SignAlert strategy too. Additionally, we are going to have a web app. In this case, this one is only going to require the web API that we just defined on the previous step, and is also going to be a consumer of SignAlert. So this is actually going to be pretty neat because the web API will be able to publish messages to SignAlert, and the web app in this case is going to be able to consume those messages as well. So if we take a look into the next step, we are going to have a background service. We name it a worker service in this case. And the worker service is going to be consuming the service bus. In this case, as a consumer of messages, it's going to be picking up those messages that we are going to be putting into the service bus. And it's going to make a quick process of those messages, and it's going to store it as part of the implementation in Cosmos DB. Additionally to that, the web app, of course, is going to be serving and consuming the web API in order to get access to different components, in this case from the HTTP request. So going into a very quick example in here, since we have a web API, I would like to show you something that is also pretty cool at the time of creating like endpoints and everything. So you can facilitate everything also using the vertical slicing when you are exposing endpoints, because instead of creating multiple controllers with a very specific multiple actions, you can create a specific definition for particular endpoints and keep things isolated and more organized, also being think as part of the API implementation. So you can see, taking advantage of this, we can go throughout the MediaTR implementation, and we can dispatch whatever command or queries we would like to make our code to execute. And once we get the response from the mediator, we can take another set of actions. I want you to take a look into this particular example. This is the delete by order point. And as you can see, we are not only sending a message through our command, in this case, to make a request to delete order from the database, but at the same time, we are sending a notification using also the MediaTR library in order to publish a notification in this case. So we have the notify by order command in this case. So if I go back to the handler and we take a look into the implementation, this is going to be an interaction between our application and SignAlert using the backend side. So as you can see, having the SignAlert injected into our code and consumed from the app host and injected into the into the web API, I am able to access the Aspire Day SignAlert instance that I created previously. And using the usual NuGet package for SignAlert, we have the capability to open a connection and invoke one of the methods that is defined into the hub that we already have defined. In this case, we are only dispatching the product ID just to let the UI know there is a new product ID that has been added to the database, or in this case, deleted. So this is a pretty neat example. At the same level, we have something to notify when a new product has been created. We take advantage, in this case, of the SignAlert instance too, and we make a dispatch to the notify GUI order as well in order to notify also from a message in this case. In the background service, we will have an implementation taking advantage of the service bus. It's actually pretty simple as well. But as you can see, this background service is going to be executing all the time. And it's going to have a connection open through against the service bus. As you can see in this particular place in here, we have a receiver. We are consuming the buy order queue that I already defined into my app host side. We open the connection and we await for any message that the user puts into our system. From here, we take this message, we process the message, and we follow a very similar approach. We create the order into the database, and we also dispatch a notification, which the web application will be able to consume in order to know there is a new item that has been processed. And after that, we close the message for the service bus. Also, adding a layer of flexibility, we have the capability to interact with our database, in this case, the Cosmos database, using Entity Framework. So once again, Entity Framework comes to the safe in here, and it allows us to treat our containers in the Cosmos DB, targeting the database and accessing those using the Entity Framework. So we can define the keys, we can access the data through our models, and using everything that we already know so far, whatever we are working with Cosmos or a SQL database is exactly the same structure. The first time that you execute this particular code, you will have, of course, as always, the Aspire resources that have been created for you. So as you can see, we have a Cosmos DB, we have a service bus, we have the SignAlert instance, and we also have our web API, web application, and our background service already running. So save time. I ran the project previously, but when you run the code the first time, it's going to happen the same thing that when you run the Aspire project the first time. The Azure Cosmos database is going to be created for you. The service bus is going to be created for you, and also the SignAlert service is going to be created into the Azure portal. At the end, you end with something like this. You have your service bus, Cosmos DB, SignAlert, and a keyword that is being used by other services, in this case, as part of a dependency. So now, following this example, we have this application in here. This is what the user is going to have the capability to interact with. So I'm going to show you as an example when we modify a record eventually that you execute. The background service is going to take that message, is going to process that message for us, and after that we are a system. So I'm going to, right now we are retrieving data from the database. I'm going to add a very basic item in here. So I'm going to say we are going to buy in 30 items with a price of 5,000. We are going to be updating those changes. The request is being set, and eventually with the message is going to go back to us. So as you can see, I made a request. The message was put into the service bus client. The worker service made a process of this particular message, and in conjunction with a SignAlert, we got a response back. One of the greatest things of building an application using this kind of design as well is the ability to keep your users in contact all together. So let me show you how this happened. So in here, we have another instance of the same application in here open. So I'm going to create an order between one of the screens, and you will be able to see, since we are taking advantage of SignAlert, we will have the capability to keep our connection open between different services. So I'm going to add a new one. I'm going to add a small quantity in here. I'm going to also add a small price in here, and I'm going to save the changes. So take a look into both screens. So as you can see, eventually we got the updates on both services, and this is one of the big promises of building event-driven applications. So you will be able to create applications that keep a full open communication between different users using the same product and making a guarantee of communication between both systems. And it's easy as it is. So you only need to define your resources that will be created for you, and you will be able to exploit all these capabilities using Aspire as your main technology. So thank you for joining me today. I would like to know if there are any questions for me.